All right. We're going to do, what are we on? 3?
3.6.
I think we're on 7. I'll look it up in a second. I have it written down. So today we are going to be transforming graphs that have an exponent larger than 2. So an x squared graph looks like this. And an x to the 4th graph, just x to the 4th with nothing else on it, would look like this. It's kind of a skinnier parabola. It doesn't have any of the geometric properties that regular parabolas have, but it's just taller. It looks skinnier, but technically it's taller. And if I had an x to the 6th, it would be even taller. And an x to the 8th would be taller. But all of the even powers have this U shape. And then all of the odd powers, like x to the 3rd, look something like this. So that would be x to the 3rd. X to the 5th would be taller, and it appears to be a little skinnier. X to the 7th would be even taller than that, and so on. Now, an x to the 7th equation can actually hit the x-axis 7 times. So it's possible for an x to the 7th to look like this. Right? But that only happens if there are other terms associated with that. It would need x to the 6ths, an x to the 5ths, an x to the 4ths, and so on. But just x to the 7th is just a taller version of x to the 3rd. So all of the evens look like u's, and then all of the odds have this funny wave to them. Does that make sense? So if I asked you to graph y equals x minus 5 to the 3rd plus 1, what is that going to look like? How would you graph this? Well, it's a regular x to the 3rd graph. And where does it move? So the x is changed by 5. Am I going to go right or left? Right. So 1, 2, 3, 4, 5. And the y's change up 1. So my new center is going to be right there. So I take this graph and I move it over and up, and that's what it looks like. Yeah, on your paper? Okay. What about what if I had y equals x plus 2 to the 4th minus 3? What is that going to look like? So we move left 2 and then down 3, and it's sort of like a parabola, but it's taller. And I don't really care if your graphs are perfect. As long as they're in the right place and they go the right direction and they're tall, then that's good enough for me. Okay. What about this? What would that one look like?
You go to the
Left 1, up 2. So it's going to look like an x to the 3rd, only taller. So it would look something like that, but the 9 makes it even taller. It doesn't even look like it has a curve to it. So it would be something that looks like that, very, very tall. What if I put 1 over 9? Then it would appear wider, and actually we would say it's shorter, but it would look something like that. Okay? Because you're actually stretching it vertically. So if I had y equals like x plus 1 squared, and I plugged in the number 4, here, that would be 4 plus 1 is 5, and the answer is 25. So on the graph, I would go right 4 and up 25. But if there's a number out front, then this would be multiplied by that number, and we would get 50. So 2 comma 25 was converted into 4. 425 was converted into 4 comma 50. And what's the difference between those 2 points? It's taller, not wider. So the movement is actually vertical. There is a way to stretch it and smash it horizontally. It's just really confusing, so we try not to do it. No, it's the actual movement. So, for instance, if I had this graph and I times the graph by 2, what you would do is you would measure all of these and then you would duplicate them. So I would put this, oh, I need to separate those out. How did I do that before? I don't know. But you would move these up. And so the new graph is exactly twice as tall as the old graph. That's why. Okay. What if I had... Oh, we need to do one more. What happens here?
So it goes down.
So this tells me right 4, up 1, and it's an x to the 3rd graph, so it's supposed to look like this, but it's upside down. But it's not, it's just a regular x to the 3rd because there's no number there. If you multiply by a number in front, then it would be taller, or if it was raised to the 5th, it would be taller. But this one's just a regular x to the 3rd. Okay, what if I had this graph? Okay. And this graph is called f of x. Okay. What would f of x plus 1 minus 2 look like? Left 1 and down 2. So I pick some points. Left 1, down 2. This point went to there. This one, left 1, down 2 would be there. Left 1, down 2. This one would be left 1, down 2. So I'm getting, and then this point would be left 1, down 2. I use those points to create the new graph. Now you can see that whole graph went left 1 and down 2. Does that make sense? Okay. So say I had this graph. And this graph is f of x. I want to graph negative f of x minus 4. So this whole graph needs to be moved down 4. So 1, 2, 3, 4. So this point went to here, this point went to here, this point went to here. And now it needs to be upside down. So that's what it would look like. Okay? All right, what if we had this? If I took f of x is x plus, let's say, x plus 2 to the 5th minus 3, and I wanted to graph 2 f of x. What would I do? Well, you would times all of this by 2 and graph it. So it's going to make it twice as tall, and this negative 3 becomes negative 6. So Originally, it was left 2 and down 6. And now it's going to be left 2 and down 12. Okay? And it's really tall. Okay, let's try another one. If I have f of x is equal to x plus 2 to the 6th plus 3, and I want to graph f of x minus 4 minus 1. What is the new equation? Well, the original equation is left 2 and up 3, but then I want to move this one right 4 and down 1. So what is the new equation? Would be so I take the original. This is the original, but I don't want to graph the original. I want to change the original according to those instructions. So I want to replace the x with x minus 4. So if I have x minus 4 plus 2, that simplifies to be x minus 2. And the way you can look at it is, this one is left 2, and this one is right 4. When you put both of those together, you end up with right 2. Everybody see that? So the f of x function says our vertex is left 2. The new function says the vertex is right 4. So if you go left 2 and then move right 4, where do you end up? 2 units to the right, which is why it's x minus 2. Yeah. So the original equation here says up 3, but this equation says down 1. So overall it would be plus 2, and now that's the one we graph. Right 2 and up 2, and an x to the 6th is a really skinny u. Do you want to see another one of those? Yeah. No, it will never be backwards. It'll look more and more like a line, though. So that's a really good question. So if I graph x to the 9th, and I zoom standard, so see that? So it comes up really fast. So x to the 11th would be like that. Well, actually, it would go straight to 1. So let's say we did x to the 21. So it's going to go straight up and then over and then maybe. See that? So the higher and higher you go, the more it's going to look like this. It'll go straight up to the -1 and then straight across and then straight up. And it'll never be straight, but the higher and higher you go, the more and more it'll look like that. All right. F of x is negative x minus 3 to the 4th plus 2. And I want to graph f of x minus 4 minus 5. So my top graph says right 3, and my bottom says right 4. So the total will be right 7. X minus 7 to the 4th. And the top one says up 2, and the bottom one says down 5. So to put them together, we'll have down 3. And we'll graph that at positive 7, negative 3. It's upside down, and it's an x to the 4th. So it'll look like that. Does that make sense? Yeah? Well, whatever, yeah. So The f function uses the fourth power, and since this is the f function, both of those stayed. So you keep everything that's already there, and then you just change it if you need to. Okay, so what if I had f of x is x minus 3 to the third plus 1, and I wanted to do the opposite of f of x. What would we do there? No, it says make everything negative. So I have to go through and make that negative and make that negative. No. Only the parenthesis would become negative and the constant would become negative. Yeah. It would flip it upside down, and instead of up 1, it would be down 1. Okay? All right. So your assignment today is 3.7. We will do 3 through 25 odd. Oh, no, never mind. 3 through 23 odd. We don't want to do 25. Okay, get to work. You can